Today, we're going to be looking at what at first seems to be an allocation problem, but on further reflection actually turns out to be a much simpler number theory problem. If we take a look at the problem stem, these numbers 143 and 77, they stick out to us. And they stick out not just because they don't seem to have any relative association, but also because they're sort of odd-looking numbers. They don't look like most of the numbers we're used to seeing, say a 48 or a 24 or a 36, something easily divisible, clearly breakable into factors. Here we're given these two disparate numbers, and we're being asked to formulate not what the tables are made up of, but how many tables there are. So we look at these two numbers, and we examine first the 77 because it's a simpler, lower number. 77 breaks into factors of 7 and 11. And this clues us in as to what to look for out of the 143. 143 must have a factor of 7 or 11. And in fact, 143 is evenly divisible by 11, and it gives us 13. Which means that there are 11 possible tables. That is, the maximum number of tables are 11. Each one has 13 people from the bride's side and 7 people from the groom's side. 13 plus 7, there's 20 people at each table, times the 11 tables is 220, and we can back check our math. 143 plus 77 is 220. We don't need to go that far, but that might help deliver some comfort to this method. So in reality, this is a very creative, clever way the GMAT is asking us for a greatest common factor. Another way to think about this is that we need an equal number of groups from the bride's side and the groom's side. Notice that the number of people on the bride's side doesn't have to equal the number of people on the groom's side. We just need them both broken into the same number of equal groups. Graphically, we can see this on the illustration as how a certain number of different size groups combine into this common table. So 13 and 7, and we have 11 groups of each. This is a great problem to problem form, and it will give you some additional mental math or common result experience by forcing you to figure out numbers that you can present that at first don't look like they match, but in fact do have a common factor. You'll notice that if they had given you something like 16 people and 36 people, finding that common factor might be easier. So as you problem form this, try and do it in a way that sort of obscures the common factor, or try it maybe where they have multiple common factors, and you tweak things like what is the greatest number, what is the fewest number of tables, or even do a perspective shift and take a look at, say, how many guests are represented at each table, or on the bride's side or on the groom's side. Of course, there are conceptual shifts to this, and you can make this story about anything. Once you control the story, or rather the structure of the story, this problem becomes very, very straightforward. Hope this helped. I look forward to seeing you guys soon.